we were discussing about a chapter called Metals and Non-metals. Let us recall what are the concepts we have discussed in this metal and non-metal. So first of all, we discussed about what are the physical properties of metals and non-metal. Before that, we discussed about that elements are classified based on the physical properties. Elements are classified into metals, non-metals and metalloids. So based on that, here first physical properties of metal. So in the physical properties of metal and non-metal, first physical property, metals are normally exhibit in solid, except mercury. Mercury is a metal, but it occurs as a liquid in room temperature. Okay. Then non-metal, first difference, non-metals are solid, liquid and gases. They occur in 3 states. Then metals are sonorous. Sonorous means sound producing. Metals can produce sound. Non-metals are non-sonorous. But based on only one property, we are not going to conclude whether it is a metal or non-metal. So we are going to see so many properties. Based on the property, we are going to consider whether it is a metal or non-metal. Then metals are lustrous, or it is also called as a shiny substance. Non-metals are non-lustrous. And then metals are malleable and ductile. Non-metals are non-malleable and non-ductile. So this is very, very important concept, malleable and ductile. So what is the meaning of malleability or malleable? So the metal can be converted into thin sheet by beating it. They can be converted into thin sheet. Then ductile, they can be drawn into thin wire. Then metals are, next property, metals are good conductor of heat and electricity. Non-metals are weak or poor conductor of or bad conductor of heat and electricity. And metals are high melting point and boiling point. Non-metals are low melting point and low boiling point. Metals are, next point, metals are hard, non-metals are soft. So these are the some of the physical properties of metals and non-metals. Already we discussed about this. So in the examination, very, very important, they are going to ask the question based on the exceptional cases. Some of the metals exhibit the property of non-metals, and some of the non-metals are going to exhibit the property of metals. So based on that, they are going to ask some questions. For example, first I already told you here, mercury. Mercury is a metal, but it exhibits non-metallic property, that is they are liquid at room temperature. Then sodium is a metal, but it is a soft metal because sodium is an alkali metal. Then non-metal, iodine is a non-metal, but it is going to exhibit the property of metal. The iodine are lustrous. And then graphite. So I told you carbon is a non-metal. Carbon exhibiting different forms. So they are called allotropy. Carbon exhibit allotropic property. Allotropy means what? Allotropy. What is the meaning of allotropy? So, allotropy means they exhibit in different physical forms, but they having a same chemical composition. They are called, or property, they are called allotropy. So, carbon, we can see the carbon in the form of coal. Coal is a form of carbon. Then soot, fluorine, and diamond is a form of carbon. Diamond is also a form of carbon. And then here diamond. Diamond is the hardest substance that occur in the nature. So these are the some of the exceptional cases we are going to study in the metals and non-metal with respect to physical properties. At least you have to write 4 points. At least you have to write 4 points. In the examination, write the properties of metal and physical properties of metal and non-metal. Like that, they are going to ask the question. So after the physical properties, we discussed about the chemical properties. We discussed about the chemical properties. So which is the first chemical property? What happens when metal reacts with or burn with the air or oxygen? So what is going to give? When a metal reacts with oxygen, when metal reacts with oxygen, it is going to give metal oxide. With respect to their metal. For example, in our book they given magnesium, Mg. Magnesium reacts with oxygen, gives magnesium oxide. So this is the first property. Suppose metal reacts with oxygen. Any metal reacts with oxygen gives metal oxide. For example, magnesium reacts with oxygen gives magnesium oxide. So it is not a balanced equation. Try to balance this equation. So in the left hand side there is a Mg. 1 into 1, 1 Mg, and here MgO is a compound. Mg is also a 1. O2 here 1 into 2, 2, here only 1 is O is only 1. So we have to balance the equation. So to make it 2, you have to multiply with 2. 2 ones are 2. Then Mg, now Mg is going to become 2 Mg. Here also I am going to put here 2. So already in the first chapter, you know how to balance the chemical equation. Definitely in the examination, they are going to ask for 3 marks. The previous year question paper, you might have seen this 3 marks questions, or it may be for ask for 1 marks, or balancing of equation, or type of chemical reaction. Okay. So first property, that is a chemical property. Any metal reacts with oxygen gives metal oxide. That is an example. One example. Then here there are some metals are there. Some metals are there. They exhibit both the properties of metal and non-metal. Metallic oxides. There are some metallic oxides are there. Some metallic oxides are there. That metallic oxides exhibit both the property of metal and non-metal, or reacts with the metallic oxide reacts with the both acids and bases, and that is going to be produce salt and water that are called amphoteric oxide. Amphoteric oxides. So this is another important question, repeated question in the examination, that is, what is amphoteric oxides? What are amphoteric oxides? Give example. So definition, of these amphoteric oxides. Amphoteric oxides. When metal oxide reacts with acids as well as base to produce salt and water is called amphoteric oxide. For example, in your book they given Al2O3, aluminium oxide. Aluminium oxide reacts with acid, for example acid HCl, hydrochloric acid. It is going to give aluminium chloride. Along with that, it is going to give water. So this is an example for amphoteric oxide. What is amphoteric oxide? When metal oxide, this is a metal oxide. The name of the metal oxide is aluminium oxide. When metal oxide reacts with acid, HCl is acid. Aluminium oxide reacts with HCl, hydrochloric acid. It is going to produce a salt that is called aluminium chloride. Along with that, it is going to give the water. So now we try to balance this equation. Balance this equation.
2 3H2.
Okay, listen here. Here, Al is 2. Al, only one Al is there. So, I will try to make it 2. Then, O3. Here, O, 1. So, 3. Then H, 2, 3 is 6. So, Cl is going to become 6. But here, 2, 3 is 6. So, once again, Al2, O3, O3, then H, 6, 3 2s are 6, Cl, 6, here 2 3s are 6. So, this is one example. Then, another example, aluminium oxide reacts with base. Commonly, we are going to use the base that is NaOH. Base NaOH. Base NaOH. So, here, aluminium oxide reacts with base. It is here also, it is going to give salt and water. What is the name of the salt? Sodium. So, the name is sodium aluminate. Sodium aluminate. Sodium, Na, O2 is the sodium aluminate. Along with that, it is going to produce water. So this is called the amphoteric oxide. Once again, what is amphoteric oxide? What is amphoteric oxide? Listen here. Here, observe here. Aluminium oxide. Metal oxides reacts with acid as well as base. It is going to produce salt and water. So this is called a amphoteric oxide. So it is a compulsory question, most repeated question. That is, what is amphoteric oxide? Give example. So after this example, you try to balance the equation. Balance the equation. Here, Al is 2. Al, only 1. Shall I put here 2? Then, O3. Here, another one O is there. 4. O. 2 2s are 4. Another one, 5. Then 2 NaOH. Na is 2 here, correct. Na is 2. Then Na, 2 Na. O, here 3. Another one, here 2. 5. Here 2 2s are 4. Another one, 5. Balanced. Al2. O3 plus here 2, 5O. Here 2 twos are 4, another 1, 5. Then H, 2H, then 2H. Okay, so this is an example for amphoteric oxide. Okay, so after this amphoteric oxide, next property we discussed about that
Metallic oxides
metallic oxides.
are soluble in water.
Ah, okay, so another important one, what happens when metals reacts with water? What happens when metal reacts with water? And also I think here all the metal does not react in same manner with oxygen. For example, sodium and potassium. Sodium and potassium are highly reactive metals. These are highly reactive metals. So that's why they are stored under kerosene. So this is another one, give reason, expected give reason, repeated question. Why sodium is preserved under kerosene? Why sodium is preserved under kerosene?
So because
Suppose if you kept the sodium in the air outside, so it is going to become sodium oxide. First it is going to become sodium oxide and finally it is going to catch us fire. So sodium, that's why sodium is preserved under kerosene. It does not react with the kerosene. Sodium does not react with the kerosene. That's why sodium is preserved always under the kerosene. And then, for example, magnesium, aluminium, how does this two reacts with the air? They react very slowly and it is going to form a thin layer of oxide. A thin layer of oxide. But the gold and silver does not react with the air. So these are the some of the metals, how the metal reacts with the air. And then next, what happens when metals reacts with the water? So another one, what happens when metal reacts with water? Instead of that, here oxygen, we are going to use the water. Listen here. For example, metal reacts with water. What is the product we are going to get? Ah, metal oxide. Metal oxide plus hydrogen. And this metal oxide reacts with water. It is going to produce metal hydroxide. It is going to give metal hydroxide. Only metal hydroxide? Metal hydroxide. Is there any release of water or hydrogen? Only it is going to give metal hydroxide. So this is the statement. Metals reacts with water, gives metal oxide plus hydrogen. This metal oxide reacts with the water and forms metal hydroxide. Then here, for example, let us take sodium. Sodium reacts with water. It is going to give what? Sodium hydroxide, NaOH plus it is going to give hydrogen. Sodium metal reacts with the water. It is going to give sodium hydroxide. Along with that, it is going to liberate the hydrogen gas. Definitely there will be a liberation of heat also. So here, balance the equation. 2Na. Why 2Na? Na. Then H is 2. Here, H is here 3. 3. 2. Then Na is going to be, H is going to become 4. Here. So to make it H4, I will put here 2. So Na, 2Na, 2Na. Then H, 4H, here 2H, another 2H is here, 4H. Then 2O, 2. So this is one example for how does metal react with water. In our book they give another example, potassium. Potassium reacts with water, gives KOH, potassium hydroxide plus liberation. Here, balance this equation. K, then H is 2 here, H is here 3. So to make it 4, I will put here 2. Then here also, I will put here 2. Then K become 2. 2K. Then 2 2s are 4. H. Here 2H, another 2H is there. And then 2O, 2. Okay. So this is the another example for how does metal react with water. So these two are highly reacts with or vigorously react with water. So it is not possible to store in water or exposed to air. That's why always the sodium is stored under the kerosene. Okay. So then another example. These two are going to be react with water, cold water, normal water. Then next another one. Example, magnesium. How does magnesium? Another one, before that, calcium. Calcium reacts with water, gives calcium hydroxide plus H2 liberation. Here, in the examination, they ask a question based on this equation. Here also there is a liberation of hydrogen gas, but it doesn't catch us fire. So calcium, if you are going to, the calcium reacts with water and form calcium hydroxide. Calcium reacts with water, gives calcium hydroxide with a liberation of hydrogen. Here, why this calcium does not catch us fire? Because sufficient amount of hydrogen is not liberated. Sufficient amount of hydrogen is not liberated to catch the fire. That's why only it is going to float on this calcium float on the surface of the water. So this is another one. You try to balance this equation. Ca, then H2, here, H is here, 4. So to make it, I will put here 2, then O, balance the Ca, then 2 into 2, 4, H, here, 2H is here, another 2H is here. So it is going to become 4. O is 2 here, and here you multiply with this 1 2s are. So this is another one example. These two are going to catch us fire, but it doesn't catch us the fire, only it makes the sound and float on the surface of the water because sufficient amount of hydrogen is not liberated to catch the fire. And then next example here, I think in our book they use magnesium. Magnesium reacts with water. Magnesium reacts with water, gives magnesium hydroxide. Magnesium hydroxide with the liberation of hydrogen gas. Magnesium is a metal. This metal reacts with the water, gives magnesium hydroxide with the liberation of hydrogen gas. So you balance this equation. Same thing. Mg, then H2 is here also 2, another 2 is here. So I will put here 2. And here 2O, 2. So here also same. Metals, these are all metals, reacts to the water, gives metallic oxides, respective metallic oxides with the liberation of hydrogen gas. Okay, then this is another example. This magnesium reacts very slowly and it is going to form a metallic hydroxide. Then here another example, aluminium reacts with water, gives what? Aluminium hydroxide. What is the formula for aluminium hydroxide? Al2O3. Al2. Hey, that is aluminium oxide. Aluminium oxide. It is going to produce Al2O3 plus here also it is going to produce hydrogen. So you balance the equation. Al2 plus H2O is here 3. H is going to be 3 2s are 6. Here also Al2, then H 3 2s are 6. O 3 1s are here also 1 3s are. So these two, magnesium and aluminium, reacts with the water and gives magnesium hydroxide and aluminium oxide with the liberation of hydrogen gas. These are going to be reacts with the cold water. Okay, so magnesium. Then next iron does not react with the hot water or cold water. It reacts with the steam, not a water. It is a form of steam is also a form of water. So Fe plus water give rise to Fe3O4 give rise to, that is going to give hydrogen gas. Fe3, then H2O4 4 2s are 8. So I will put here 4 2s are 8. 3Fe, then H 4 2s are 8, 4O. Okay, so this is about the how does metal reacts with the water. Sir?